Welcome to Skillzam, a cure platform, cross-skill, upskill, reskill and expert skill. We are your best learning partner for life. Skillzam, keep learning. Welcome to the Skillzam section on electricity to bits. In this section, you will learn about transistors and its properties and how this transistor acts as a switch to generate two basic representation of binary, that is on or off, true or false, or 1 or 0. Transistors. In 1948, the world advanced by the birth of transistors, an event that was forever changed the course of computers and electronics. A transistor is a semiconductor device used to amplify or switch electronic signals and electrical power. Now the question is, what is a semiconductor? Well, a semiconductor material has an electrical conductivity value falling between that of a conductor and an insulator. The second generation of computers were based on transistors, whereas the first generation was mechanical and vacuum tube computers. Transistors as a switch. The transistor is a fundamental building block of electronic circuits where they are used as on-off switches. You have learned that a wire can either have a voltage or not have a voltage on it. The reality is more complicated. The on-off picture of a wire, a transistor, or a logic gate output is a simplification and abstraction. This is a rough graph of actual input-output behavior of a transistor. So don't worry about the details. Just notice two blue flat parts of the graph. Within the cutoff region, small changes to the input voltage do not change the output voltage at all. The output is always 0 volts. Likewise, within the saturation region, some input changes hardly impact the output voltage. The output is interpreted as 1. This is how transistors are used as switches in a computer. Transistors are versatile devices. When used in the middle linear, that is, pink part of the graph, they are amplifiers. A small variation in input voltage produces a large variation in the output voltage. That's how they are used to play music in a stereo. Electricity wire to bits. In a computer, information travels over wires. The easiest way to convey information in a wire is to consider it on or off based on how much electricity is going through it. The top wire has a lightning bolt going through it, representing an electricity switch like a transistor. When a transistor switch is turned on, an electricity passes through the wire and an on wire represents 1. Similarly, when the transistor switch is off, an electricity does not pass through the wire and off represents 0. This piece of information is called a bit, and it's the smallest piece of information that computer processes, that is on or off, which can be 1 or 0. A single wire can only represent 1 bit, one piece of information. We can represent the results of a flip of a coin with a single bit by saying that 0 represents tails, 1 represents heads. But we usually need to represent much more information than that in a computer. So the solution? More wires. Each wire adds an additional bit of information, an extra bit that can be considered on or off, 1 or 0. This means we add more wires, that it means more bits. In computers, we use bits to represent numbers using the binary number system. Abstraction and transistors. In actuality, a wire isn't exactly on or exactly off. That's an abstraction that simplifies the details of how computer works. We use abstraction often in computer science so that we can more easily understand the system that we are building. Let's deep dive in understanding how abstraction works. A wire can have varying amounts of electricity flowing through it, but the computer needs to be able to interpret the electricity in the wire as either definitely 0 or definitely 1. The transistors can be used as digital switch in computers. The transistor turns on when electricity is enough flows through and stays off otherwise. How much electricity is enough? Well, that depends on the transistor and its threshold voltage. If an engineer uses a transistor with a threshold voltage of 6.5 volts, then any voltage of 6.5 or higher will turn the transistor on. At a lower voltage, the transistor stays off. So now let us consider an example here. This top wire has electricity pulsing through it at 6.5 volts and comes out of the transistor in the state on, labeled as 1. The second wire has electricity pulsing through it at 5.5 volts and comes out of the transistor in the on state, labeled as 1. Similarly, the third wire has an amount of electricity pulsing through it at 0.1 volts and comes out of the transistor in the off state, labeled as 0. Consider a computer that needs to determine whether a USB cable is plugged in. When you plug the cable of a mouse in a computer's USB port, a circuitry in the mouse uses the voltage provided by the port to pull up the voltage in the cable above 3.3 volts. In the computer, a transistor detects the high voltage and translates it to 1 or on. This bit of information tells your computer that the USB device is plugged into the port. There's a variety of transistors. Engineers choose the transistors that are best fit for the job by considering characteristics like threshold voltage, material, and the size. The transistors inside your computers are so small we could need a high-powered microscope to see them. However, transistors are also used in other electrical projects, and those transistors are the ones you could pick up on your fingers. An important takeaway here is that computers are built on layers of abstraction, like bits abstraction on top of transistors. Those layers enable computer scientists to use and control computers in a more predictable ways. This marks the completion of this section. This section demonstrated that simple electricity wire carries the unit of information that computers can understand. This also shows that transistors are the means for the computer to understand the zeros and ones. Thank you for learning with Skillzam and never stop learning.